Hi everyone, today we are going to do Unit 1, Lesson 2. It's about a special right triangle called the 45-45-90 triangle, and you might remember learning this in Geometry and Algebra 2. This is a review of something you've learned before, but I am going to show you a different technique today that you could use for finding missing sides of some of these special right triangles. First, I want you to remember that 45-45-90 triangles are all similar to each other. They have at least two angles that are congruent, and that makes them all the same shape, just different sizes. And it means that all of their sides have the same ratios to each other. And from triangle to triangle, they will be proportional. Use the Pythagorean theorem to solve for the length of the diagonal of a square. One thing you know about a square is all the sides are congruent. So if one side is x, they're all x. The angles in a square are all 90 degrees, or right angles. The diagonals bisect those angles. And so this corner over here would be bisected into two 45-degree angles, and same with down here. The diagonal of a square will bisect the angles. Let's call the diagonal D. Now what you'll notice is if we take half of the square, we wind up with a triangle that is a 45-45-90 triangle. So let's work with that. We're going to use the Pythagorean theorem to solve for the length of the diagonal. Remember the Pythagorean theorem, a squared plus b squared equals c squared. And your legs are your a and your b. So our legs are going to be x squared plus x squared, and the diagonal is our c, so equals d squared. X squared plus x squared, they're like terms. If you add them, you get 2x squareds. Remember, we're trying to solve for the length of the diagonal. So we don't want d squared. To get just regular d, we're going to have to take the square root of both sides. And when we do that, we will just get plain d over there on the right. But on the left, we have to think about this. If we take the square root of 2, is it a nice number? No, and no perfect squares divide into it. So we'll leave the root 2 or the 2 under the radical sign. But the square root of x squared is x. So we have solved as low as we can go for the length of the diagonal. What we just showed is if you have a 45-45-90 triangle, then no matter what your legs are, they'll be the same length, so we'll call them x. The diagonal will be x times root 2. All of these sides have at least an x in common, so I want you to think about if we have a 45-45-90 triangle and all of the sides have an x in them, what if we divided them all by x? As long as we do it to all the sides, it should be okay. It should still be in balance. And x divided by x is 1, so the ratio of the legs is 1 to 1. And then think about up here on the diagonal, the x's would cancel out and you would just have root 2. So what I really want you to remember is if you have a 45-45-90 triangle, the ratio of the legs is 1 to 1, and the ratio of the legs to the diagonal is 1 to root 2. This will be the case in every single 45-45-90 triangle. For today's homework, all of your answers need to be exact answers. We don't want any decimals in your answers. So here's what some of those questions might look like. You can see off to the side we have a 45-45-90 triangle. These have a ratio of 1 to 1 to root 2. And in this case, we're working with AC and AB. So the ratio of AC to AB is 1 to root 2. Now AC is 12 and we want to find AB. So that ratio is 12, and we'll just say 12 to x since we don't know what AB is. To solve a proportion like this, you cross multiply. So we're going to multiply 1 times x and 12 times root 2. 1 times x is x. 12 times root 2 is 12 root 2. Again, you want to have an exact answer, so you want to think, can I simplify this any further? And the answer really is no, because root 2, no perfect squares divide into that, and so it's as low as it can go under that radical, and so 12 root 2 would be the length of AB. Now some of you remember doing this a different way. if you know the length of the leg, you just multiply by root 2 to get the length of the hypotenuse. So really think about, we had 12 and we just multiplied by root 2, we got 12 root 2. If you want to do it that way, you sure can. We're going to get to a couple more complicated questions later in this unit, and so sometimes the proportion is a nice way to solve those, but really feel free to do whatever way works for you. Let's try part B. So in this case, we're working with AB and BC. The ratio of AB to BC is root 2 to 1. Now we know AB is 3. We want to find BC. Set up your proportion, cross multiply. 3 times 1 is 3. X times root 2 is x root 2. We're trying to solve for x, and so what we need to do is get x by itself. We're going to divide by root 2 on each side. These will cancel out. Is 3 over root 2 considered to be simplified? No, it is not. And so then what we have to do is we have to rationalize the denominator. We have to multiply by root 2 over root 2, and we're going to wind up with x equals 3 root 2 over 2. Let's try part C. In this case, we're working with BC and AB. BC and AB have a ratio of 1 to root 2. BC is 5 root 2. AB is what we're looking for. Cross multiply. 1 times x is x. Think about 5 root 2 times root 2. Root 2 times root 2 is just plain old 2, so it's really 5 times 2, which is 10. So the length of AB in this case would be 10. Example 2, part A. This time we are working with another 45, 45, 90 triangle. Remember, they have a ratio of 1 to 1 to root 2. So MN is 4 root 2, and we want to find MP. So MN and MP have a ratio of 1 to root 2. I know MN is 4 root 2, and I want to find MP. Cross multiply, you get x equals 4 root 2 times root 2, which is 4 times regular 2, which is 8. Let's try part B. This time we're working with MP and NP. Now MP has a ratio of root 2 to 1 with NP. MP is 2 root 6. NP we don't know. Now we cross multiply. So we have x root 2 equals, and then when we cross multiply this way, it's 1 times 2 root 6, which is just 2 root 6. All right, we're trying to solve for x. To get x by itself, we're going to have to divide by root 2. These will cancel out. Now, 2 root 6, think of that as root 2 times root 3, because then you can actually just cancel out these root 2's. And your final answer is going to be 2 root 3, which is going to be NP. Example 3. Do we even know if this is a 45, 45, 90 triangle? It doesn't say anything about being 45-degree angles at A or B, but think about this. The angles in every triangle add up to 180. In this case, if two sides are equal, this is an isosceles triangle. In an isosceles triangle, it will also have two congruent angles, and they're across from the congruent sides. So A and B should be congruent angles. Now, if they add up to 180, take 180 minus the corner that you already have, which is 90. You have 90 left, which has to be broken up equally for angles A and B. So angle A and angle B will each be 45 degrees. Therefore, we do have a 45, 45, 90 triangle, even though they weren't written in. Remember the ratio. The legs have a ratio of 1 to 1, which have a ratio of 1 to root 2 with the diagonal or the hypotenuse. Okay, so in this case, we're working with AC and BC. Now, AC and BC have a ratio of 1 to 1. So if AC is 16 and you have to find BC, you could set up a proportion. If you cross multiply, you get x equals 16, which makes sense because they should be the same size. Next one, we're working with AC and AB. This time our ratio is 1 to root 2. AC is 16, we want to find AB, we'll call that x. Cross multiply, you should get x equals 16 root 2, which means AB is 16 root 2. Part C. We're working with AB and BC. AB and BC have a ratio of root 2 to 1. So AB is 24, we want to find BC. Cross multiply. We have x times root 2 and 1 times 24. So x root 2 equals 24. To solve for x, we're going to have to divide by root 2. These will cancel out. So we have x equals 24 over root 2, but you cannot leave a radical on the bottom of a fraction. And so we want to rationalize the denominator. So you're going to multiply by root 2 over root 2. On the top, we get 24 root 2. On the bottom, we get plain old 2. 24 divided by 2 is 12. So we wind up with 12 root 2, which is BC. Last but not least, let's try part D. So this time we're working with BC and AB. BC and AB have a ratio of 1 to root 2. So we take the 7 root 3 and we want to find AB. Cross multiply. 1 times x is x. And then we have 7 root 3 times root 2. And these, you actually multiply the radicals, so you get 7 root 6. 7 root 6 is AB. All right, please pause the video, try these 3 questions. Remember, you have to have exact answers, no decimals. And then when you're done, unpause the video to check to see if you got them right. So here's my work for each of these questions. Go ahead and pause the video again, check your answers, check your work, see how you did. Example 4. As you can see, we actually have 2 45, 45, 90 triangles here. Even though they didn't fill in the third angles, we do know those would have to be 45s because in every triangle, the angles add up to 180. Now my advice here, when you have a side in one triangle and you have to use it to try to find a side in another triangle, is first solve for a side that the triangles have in common. So I'm going to jot that down, and I want you to also first solve for a side that the triangles have in common. So in this case, I'm going to try to solve for this side first because the triangles share that side. Remember, all 45, 45, 90 triangles have a ratio of 1 to 1 to root 2. And I'm going to call this side y just so that I can call it something in my proportion. So if I'm working with the 9 and this hypotenuse, they have a ratio of 1 to root 2. I know the 9, I want to find y. Cross multiply. Y equals 9 root 2. So basically we just figured out, I'm going to do a little erasing here. I just figured out this side is 9 root 2. Now I'm going to use the second triangle. Let me outline that in green. So I'm going to use this triangle right here, which I'm outlining in green, and I'm going to use the 9 root 2 to try to find x. So the second thing that I want you to do, and go ahead and jot this down too, is then solve for the variable. And in this case, our variable is x. So I'm going to use the 9 root 2 side. Now this is a little confusing because now we're using this green triangle, and the ratio of the sides here is 1 to 1 to root 2. So the 9 root 2 goes with the 1, and I'm trying to solve the root 2. So again, my ratio is 1 to root 2, and then 9 root 2 goes with the leg, and I want to try to solve for x. Cross multiply. So when I cross multiply, I'm going to get x equals 9 root 2 times root 2, which is 9 times root 4, or regular 2, and that is 18. So x equals 18. Well, hopefully you're feeling pretty confident and you can say, I can find the exact measurement of a side of a 45, 45, 90 special right triangle. Next, you're going to try Unit 1, Practice 2. If you get stuck, just send your teacher a Schoology message and we will help you out. Good luck. Have a great day.